Welcome everyone to another observability clinic. Today's topic is use cases for anomaly detection based on DQL. We had a session that was called Introduction to Anomaly Detection based on DQL a couple of weeks ago. So folks, if you have not seen this but interested in the introduction, check out the links in the description of the video. Today I have two guests, David and Wolfgang. Hi, grüß euch.
Servus.
Hey, everybody.
Hi. Hey, thank you so much for this. And as we always we like to get fast into the things that we're actually going to learn today. So I think, David, you are going to kick us off with a little of a recap, and then Wolfgang, you have a demo prepared for us because this is really what people love about these observability clinics, seeing things live in action. With this, I want to hand it over to David. Take it away.
Great. So, as I said, what we learned today. So today I give just a short recap from our last session about anomaly detection on Grail and focus on three important segments that Davis Anomaly Detection is based on. And after that, we jump directly to the use case, to the data observability, as already promised that we continue in the next session on the use cases. And on this, we will show an action by Wolfgang. So recap. So as again, I highly recommend you to watch the last session where I explain on the generic way about the feature Davis Anomaly Detection, where you see how you use it on notebooks and dashboards, and also how you create an anomaly detector. So overall, I always said Davis AI covers a lot of use cases out of the box in observability, in infrastructure monitoring, in security, and so on. But it's always based on your business domain requirements. There's always a special requirement you want to create anomaly detection. Yeah, and to do so, you will use mostly using DQL to find your time series data for your requirement. And on that time series data, you can create an alert on that. Not only time series by itself, it can also coming from events, logs, or BIS events. And we also gain the power, of course, on TQL that you can also join two time series together on your, if it's needed, or you have a time series data that's get the influence over time by a specific log event, by error, or BIS events, and so on. So if you have your TQL together, you can on top, you can place your Davis Analyzer anomaly detection on that to identify what is normal, what is abnormal. Yeah. So we have three analyzers on place for anomaly detection: is static threshold, auto depth threshold, and seasonal baseline. And I promise you in the future, there will be in addition more analyzer where you can play around to simulate and should be help your use cases. After that, if you have the two segments in place, you can also then create the Davis Anomaly Detector, where you have a scheduler monitor your time series data or your use case every minute and check which is normal and abnormal. And when the violation has fulfilled your requirement, then it's triggered an event. Yeah, and this event can trigger then a workflow, can trigger Davis problems, or you get notified and so on. Yeah. To see that in action, I would like to hand over then to Wolfgang to see what it is, or the use case specific. Wolfgang.
Thanks, David, for giving us the introduction. So one of the use cases that I would like to present today is data observability. So unlike the typical examples that you are used to from Dynatrace, like infrastructure monitoring, service monitoring, application monitoring, we are now in the situation that we can cover much more by the underlying Grail and DQL flexibility, right? And one of those topics that we encountered ourselves and of course in customer environments is that there is a tremendous need to safeguard ETL data pipelines by using all means that you have in place. And in this case, this means that we would like to apply Davis Anomaly Detection to safeguard our data processing and the collection of business and reporting data in a data pipeline. So one of the topics that I would like to mention here is that we see a tremendous increase in the kind of data fabrics that companies use worldwide in order to derive business decisions on top of that data. And that is not only observability data, but also includes BC event data, business information, any kind of usage data, everything that a modern company collects on a day-to-day basis is transported through a data fabric and is used then by high-level management in order to derive intelligent and smart decisions on top. And Gartner sees that as one of the crucial success factors going forward, right, for modern companies. And how does a modern data pipeline look like as an example? Let's see that quickly. I took an example from a typical very small scale AWS deployed ETL process that transports pieces of data packages from all kinds of sources through typical AWS components like Lambda functions, S3 buckets, and so on. And for sure, you know that from your own company that those data collection pipelines fulfilling Power BI or business intelligence dashboards and reports are tending to grow very complex fabrics. So that's for sure. Our own data pipeline looks much more complex than this small example here. And each of those ETL steps or moves sensitive information, a large bunch of sensitive information on a regular basis, and companies take decisions depending on those data transports and ETL processing pipelines. And you see a dashboard on the right where you see a global dashboard of visualizing something, right? Can be anything. Now, the question is, what happens if one of those steps doesn't provide the necessary information and the data package? And that's very, very hard to detect in reality because those data pipelines, they consist of hundreds or thousands individual processes moving pieces of data in different schedules from point A to point B until it reaches the report. So on high level, you might not even recognize that there is data missing because your chart looks like yesterday, right? Or the world map looks like yesterday, but underneath there is important information missing. Can you go to the next? Yeah, and there are 5 very important pillars to safeguard your data running through those pipelines, right? So number 1 is data freshness. Data freshness means how old is the data that my report or dashboard shows currently. So maybe the data was collected a day before, but is then traversing through the ETL pipeline in a very slower pace, right? And maybe you are always looking at outdated data, right? So that's the data freshness. Distribution means what kind of regions, what kind of dimensionality are you typically looking at? And did that change over the last couple of days, weeks, month period of time? Data volume is one of the most important aspects here, as it counts or it delivers the information how much data volume you are transporting over time, and if the volume is consistent and offers and shows all the available data, or if is there a batch of data missing from a region. Just think about you're collecting worldwide sales revenue in a decentralized ETL pipeline, and then you are missing out on the European markets. to collect the data. So your business dashboard is then empty on the European side, right? And you would like to avoid that. So that is the volume. Schema gives you the information on what kind of dimensionality, what kind of regions you are collecting the data. And Lineage, last but not least, measures how the data is transported from one step of the ETL pipeline to the next, right? So typically, Lineage is safeguarded by applying and deploying Dynatrace agents on the individual ETL pipeline steps in order to safeguard that the hosts and those compute boxes are still up and running when you need them, right? But what I would like to show you today in a live demo is how you can use anomaly detection to cover some aspects of your ETL pipeline, like data freshness and data volume. And for that purpose, I would like to share my screen. Let me switch.
And as you're sharing your screen, Wolfgang, just for me to
Sure.
recap, what I really liked about this, if I understand it correctly, we are basically observing metrics that we extract from the actual data pipeline. So we're extracting data from the data as the data moves from the creation until the data ends up on a business report. And these 5 dimensions are critical dimensions to actually let us understand the quality of the data that we have. And we can use anomaly detection to figure out if anywhere along that pipeline we have an anomaly, because data either doesn't come in the volume we expect, and the freshness is something else is wrong. That's the data.
Exactly.
Observing the data with data. Look at, I mean, it's amazing.
Exactly. Observing the data and the meta information. So it's like the meta information and the meta model of your own company data by using Dynatrace and Grail and anomaly detection, of course.
Perfect.
So let's look at some examples here. So first of all, I would like to show you that in a typical case, a lot of information is coming in through log lines. That's pretty natural, I would say, as ETL batch processes are fire and forget processes in the most cases. So they run once a day, once an hour, depending on your company's schedule and depending on the data sources, right? So typically sales revenue numbers are collected at the end of the business day for each region. So that also means that it comes in different time zones, different schedules at the end of a business day. And the information that something was successful or not is coming in through a log line, right? It's not a classic metric as such, it's a log line. And the batch processor or the batch process is writing an event with a very arbitrary content here that depends on your batch processing ETL process. And in my case, it's writing a single statement that says table row successfully imported. But that can be very different in your case, right? It also adds the information about what job wrote that log line. And that is just information level information, right? So no crash, nothing, everything was okay. And the information that raw data for the table billing was imported for a specific tenant. Of course, that is demo data that I prepared for. But you see that there is a lot of information hidden in that single log line, which says which ETL job is responsible for successfully writing the information, which table it is, so it's the table billing, and for which tenant this is relevant. I also have that information as a log tag attached here that you can further use for filtering and aggregating by using Grail. So now that we know that our ETL job writes a successful log line every time it imports data, right? Now we can use DQL and Grail in order to count how many of those statements we have during a typical day. So let's say last 24 hours, we run the analytics here, and you see that we typically have around 27 of those successful logline imports on a 10-minute basis, right? So the schedule is defined on top of the Grail process. And what you can already see here is that I applied anomaly detection on top in order to get a nice visual band of showing me what is a typical normal band. And the normal band here is actually calculated between 24 and 28, right? So, and I can also show that here, that auto-adaptive threshold is used here with a number of signal fluctuations, which is the sensitivity that I would like to apply in order to make the band more narrow or not, right? And I would like to alert if the measured number of those log lines is outside this green band, right? So I could go, for example, for last 7 days and check what's the typical case. And you already see that I get some violations here where the number of those collected ETL job log lines is outside the normal band, right?
So
So
also for
now,
clarification, maybe
yeah,
Wolfgang, because people, when they see things like alerting, some maybe or interpret this as we're actually sending alerts. We're here in the dashboard or in a notebook. This is just the settings for the visualization, and the alert in
yes,
this case means we see where an alert would have been triggered. Also, if you would use this, I guess, for a custom alert that you can do on these type of data points. So you can get alerts if you want, but this is not just visually.
exactly. So the annotation here states that it's a simulated potential alert. So if you go with those settings,
Perfect.
you would have ended up in the last 7 days with 3 alerts where the data was outside what we measured being the norm. We can now play around, of course, and say, okay, I would like to have it less sensitive. And the nice and really powerful thing here is that you can play around with your data, right? You can make it less sensitive, more sensitive. You can change the filter here directly on the log line. Or you can even merge and join with metrics. That's really the power of Grail and the power of anomaly detection analysis on top of Grail that where we can do such simulations on the fly. But now let's say we are pretty fine with that simulation here, and we would like to get an alert in case this really happens and if the data really jumps outside the normal band. And for this purpose, you can easily open this configuration with the newly introduced Davis Anomaly Detection application here in order to configure a single detector that then is regularly doing the evaluation for you, right, day and night, in order to inform you by raising violation events. And let's state here data observability is my topic here. This title line is just to organize my detectors, because in the end you will have thousands of detectors, of course, and give it a meaningful description so that your coworkers know what your detector actually does. So sorry for my typing. Measures data volume abnormalities. And the source here is notebooks, which is just a textual indicator where was the source where I created it. Here we already have my query taken from the notebook, so that's already configured. You don't have to do anything here, so that's pretty convenient. And the same for the model parameters here that were automatically taken from the notebook. So you always start in the notebook exploring and then jump to the configuration to configure your detector. But where we need some input here from a user is now how the violation event should be called. So I could call it alert on abnormal ETL data volume. I can put in here some additional longer textual description, including Markdown. So if you want to add a playbook link here, you can do that here.
That's pretty cool. Wow.
So for your coworkers, if you know already what you want to do in that case, right? Like restarting the ETL process, then it's good to put a link here to inform your coworkers. And then you can use source side tagging for attaching any kind of information onto that violation event. Like I'm entering my own name here. So, but the takes can be more reasonable, of course. And then we have last run, and the anomaly detector was created. And from this point on, this detector is automatically running and alerting in case of violations in the data volume. You see some important columns here. You can add more, like seeing the modifier date and showing all the information, like the model parameters, event name, and when it was last modified. And an important thing here is the status, which means that only if the status is showing successful, our detector is running in a regular state. Once the status is showing some errors, you can cross-check on a notebook again why your DQL queries are either timing out or are failing for some reason, right? So you always have to make sure that this is in success state here in order to run the anomaly detector in a active and regular way.
Wolfgang, one quick question.
Yeah, sure.
How often, because you mentioned that now, first of all, this is a beautiful workflow from an end user journey perspective. You start in the notebook, you play around with your data, you play around with the anomaly settings, and then you say, now I really want to kind of, create an active anomaly detection definition. How often now will these rules be evaluated?
Every minute.
Every
So we
minute. Okay.
evaluate every detector every minute, right?
Mm-hmm.
So that's these anomaly detectors are built for real-time alerting, right?
Cool. Perfect. Yeah.
In the future, we will also offer less regular schedules, like every 10 minutes, every 15 minutes. That's for the purpose in case that you want to detect anomalies, but the schedule of the incoming data is not that regular, like once a day or so, then it could be beneficial to run it once an hour, for example.
Yeah, I guess you could then also, for very specific special use cases, even use a workflow that is
Yes,
then triggered to
exactly.
an event, because all of these anomaly detection rules, as you have shown earlier, are available both in the notebook, in the dashboards here, and also in the workflows. So
And in the workflows, I can quickly show that. So if you want to trigger it once, fixed time interval once every 30 minutes, for example, it's easy to add the anomaly detector here as a custom step here, like auto adaptive threshold. You put in the the query and the model parameters. You can also jump from the notebook again, right?
Perfect.
And then you evaluate what you would like to do with that violation event.
I want to
But
add
now,
something.
yeah,
Because we have an interval. It's like, okay, every 5 minutes we're checking every 5 minutes how is it. But we're also introducing in future also like I want to scale up once a day, but it take the last 24 hours. So we're checking every minute from the last 24 hours. So it's more, let's say, in blocks, I would say. And here is like an interval. So we'll be providing two concepts then in the future.
Yes. Okay, so jumping back to my second example, which even shows more of the power of Grail, right? This was a pretty simple example, counting the incoming number of log lines of a certain pattern. But now I will show you something that is really cool, actually, I would say. So check for data freshness. So the question is, how could you measure the freshness of incoming data? So let's say you have an ETL process that collects relational database row counts on an hourly basis, right? And that data is only collected every hour, but for the hour before or for the day before. So in this case, let me show you the log line again. In this case, we have two timestamps here on my log line. One is the timestamp when Grail and Dynatrace receives the log line. And in the content of the log line, you have a second timestamp that differs from the receiving timestamp, where the batch processor actually has, or the source of the data actually has the possibility to write down in the content of the log line when the data was actually collected. So meaning if you have a 100-step ETL pipeline and some lazy guy is not forwarding the data, right? The log source can actually state that the data was fresh at the source, but it's late at the end, right? So that's essential information to debug the functionality of your ETL process. Okay, now how do you process that kind of information? And in Grail, that's pretty simple, because what we can do is actually we can first of all, we filter for the table log lines again, and then we are parsing the content of the log line in order to get the second timestamp out, right? And then having the second timestamp coming from the source, we are calculating the delta between the Grail timestamp, so the incoming timestamp, and the source's timestamp. And what this delivers actually is a measurement of the latency, right, from source to Dynatrace. And if we run this, we see that typically the latency is here 0, and then it jumps to nearly, I think it's nearly 1.5 hours here. And I produce that example, of course, once a day. The source is basically, or the ETL process is not forwarding the data immediately, but waits an hour for whatever reason, resource contention, a delay in the network, whatever. So data is then stored and forwarded later. But here in the latency measurement, we can already see that. And I get an alert, right? Once this happens, in order to react and to debug my ETL process. And that's essential if you want to debug all those components that are forwarding your data. And again, as you can see here, I'm opening it again with the anomaly detector application, and I'm discarding this. And I already configured one of those data freshness anomaly detectors here that exactly shows this measurement of calculating the delta, the freshness of the data, and raising an abnormal ETL data freshness problem here, adding all the necessary information, right?
Very cool.
And that really shows the power of Grail, right? Along with the possibility to debug and to dive deeper into the functionality of your ETL process and the hundreds of individual components that all write different log lines and different formats, right? And Grail gives you the power, together with anomaly detection, to debug and to alert on critical data forwarding situations.
And I think the beauty of this is not constrained to your ETL process. Any type of business process, anything where you're moving data or creating data along an end-to-end journey, you can now use Dynatrace to get alerted on if there's anything abnormal along that process, right? If you think about, I mean, this was a perfect use case of an ETL, but coming to the business side, you could say I have a strange behavior between somebody is purchasing a product until it gets delivered, and we have data sources on both sides. When something is purchased and delivered, and something is abnormal, that is fantastic.
Exactly. So for business and purchases purposes, you probably would replace the logs here with fetching BC events and doing the same calculation, right?
Yeah. Or I think as Klaus has shown in one of the previous sessions we did on business events, you could obviously also have external tools, external vendors. Like thinking about the business example, you may have an organization that is doing the delivery for you, delivery services. They may provide this data by streaming their logs to you, whether it's logs or business events, then it doesn't matter. But really powerful. And what I really like about this, even though I repeat myself now, is you really thought through the journey of a data analyst or data scientist and saying, first I want to see if my data is here. What does my data look like? How can I get I think you had 5 dimensions of data freshness. You had your volume and all these things. How do I get this data out of my current process? What is a normal behavior? Then you can play around with your anomaly detection, see how much you would get if you would get the alerts, and then you just sign up for creating that anomaly detection rule. It's really cool.
Exactly. Yeah, and with that, I'm at the end of my demonstration, and hopefully I did show the power of anomaly detectors applied to the domain of data observability. And I'm handing back to Andy.
Yeah. Thank you so much to both of you. First of all, there is more content that is available. We have links to documentation, links to the previous recording. So folks, if you're looking at this, please check the description of this video. You'll find the links there. If you're watching this on Dynatrace University, you will also find the slide deck that David has prepared, and there's also links in the end. There will also be more use cases. So what I really like is that we are not only showing you a feature, but we're really showing you how we apply the capabilities of Dynatrace to specific use cases. And this is why I'm very grateful and thankful to both of you to show us how this is done.
Thanks, Andy, for hosting us.
Of course.
Thank
always.
you very much for that.
Always. All right.
Next session.
Yeah. Thank you. Bye-bye, everyone.
Thank you.
Bye-bye, everyone.
Bye.